Okay, this is Mr. Long, and we're going to start our 7th stoichiometry video. Now, there's one change I made on the last stoichiometry video. I decided to go back and renumber my examples and the homework problems from the beginning. But just going back on stoichiometry, because I thought it was best not to have examples 1 and 2, 1 and 2, or homeworks 1, 2, and 1, 2, and so forth. So I'm going to go like 1 through 20 or something. So anyway, what I did was on the last video, or on the 5th video, I made this example 10 and homework 10. Okay, and on the 6th video, I decided to make this example 11 and homework 11. I think I'll be able to keep up with your work better that way. So anyway, this is the 7th stoichiometry video, and we're going to go just the opposite route now, volume A to mass A. So you just look at our stoichiometry roadmap. Volume A to moles A, we're going to use the magic number of 22.4 liters of a gas at STP and 1 mole of that gas, and then go from moles A to mass A using the periodic table. So we're going to go this way on when we solve for these problems. So anyway, example 12. How many grams, that's mass, of O2, so it's how many, so you go into there, are in 3.8 liters of O2 at STP. So we're starting right up here. Okay, so it's always good to write on the where you're going on the roadmap. So we're starting with 3.8 liters of O2. That may bring this up a little bit. Okay. So anyway, and so we're going from volume A to moles A. So at the bottom here, the next step, if we got liters of O2 to begin with, we've got liters of O2 in this next step. And so by liters will be the 22.4 to 1 mole of O2. So we know this because we're starting with liters of O2. That's right there, you have a specific amount. So you write that down first. So whatever this unit is, if it's an elephant, you got to have an elephant down here so they can cancel out. So you can put 22.4 liters of O2 is equal to 1 mole of O2 at STP. So now we've gone from volume A to moles A, but we want to go to mass A because we're asked how many grams. So if this is an apple, you've got to have an apple down here. So we're going to have moles of O2 down here, and in 1 mole of O2 we're going to have so many grams of O2. Now, where do we get that from? Well, we're going to use that periodic table again, and everybody knows what the mass of oxygen is. It's 16.0, so you don't have to write it out here because you got it committed. So, but it's 16.0, but we'll put this down anyway. Oxygen is equal to 16.0 times 2, because some folks might make that mistake, equals 32.0 times 2. So you get 32.0 grams of O2 are equal to 1 mole of O2. So now we're in mass. So it's a two-step problem. So we just cancel out those units and those units. And so let's pull our numbers over. We've got 3.8. and the ones drop out, times 32.0 divided by, you don't put a parenthesis there because there's only one number to do, so we get 22.4 is equal to. And so let's get out the old calculator again, and let me find, here it is. So I'll put it down here so we can see. So we got 3.8 times 32. So that's 121.6 divided by 22.4. And that's going to be 5.42, or 5.4. That's 5.4 because we're going to stay to the tenths again. And we're in grams of O2, grams of O2. Put a little rectangle down around that guy. So that makes it good. So there you go. So what you start with, and you go into from volume A to moles A, and you're going to use the 22.4 liters there. And then you're going from moles A to mass A using the periodic table, which we've done here, and we get this. Now, the problem for you guys to do, homework 12, how many grams of nitrogen gas are in 12.4 liters of nitrogen gas? So what do? What do you start with? Well, you are starting with 12.4 liters of N2. And you're going to do it exactly like we've done up here at this problem. But look at your roadmap so you understand what you're doing. Okay? So there you go, and I'll see you shortly on the next video.